This looks like a target for the quotient rule. That root isn't doing us any favors, so I'm going to rewrite that before we get going. This is 7x to the 1/2 over, and the denominator's all right, x squared minus 4x. Okay, so the derivative of this, df dx, is the bottom times derivative of the top minus the top times derivative of the bottom, which is 2x minus 4, all over the bottom squared. Again, I'm not going to expand that. It generally doesn't benefit us to do so, but we will expand the numerator and see if we can get some like terms. So x squared times this would be 7 over 2x to the 3 over 2. Minus 4 times 7 over 2 is minus 28 over 2, which is minus 14, x to the 1/2. Minus 7x to the half times 2 is minus 14x to the half. No, I'm sorry, x to the half times x, so it's x to the 3 over 2. That's better. Minus 7 times 2 is minus 14, x to the half times x to the 2 over 2 gives 3 over 2. Yeah, that's good. And minus 7 times minus 4 is plus 28x to the 1/2. Okay, we have like terms and plenty of them. Actually, because there are like terms, I need a common denominator here. This is 14 over 1, which I will now replace with 28 over 2. I want a common denominator with this term so I can add them together. So goodbye 14 over 1. Hello 28 over 2. Oh, and let us not forget all this is over x squared minus 4x all squared. So our finished derivative should look like 7 over 2 minus 28 over 2 is minus 21 over 2. And minus 14 plus 28 is plus 14 x to the half. And all that is over x squared minus 4x all squared. It bugs me a little bit to have this fraction in the numerator. You could replace that with 10.5 if you wanted, or if you want to not have any fractions at all, you could double the entire top and double the entire bottom. And if you do that, you get minus 21 x to the 3 over 2 plus double this term also, 28 x to the 1/2, and then downstairs you would have a 2 because you're doubling the denominator, and the rest of this remains. Is that better? I'm not sure. I think I slightly prefer this, but I wouldn't blame somebody for giving this version, even though that fraction within a fraction vexes me a little. They're both valid, and they're mathematically the same.